Hello and welcome to ISCW Lab number 4. In Lab number 4, we're going to make an iOS router act like a firewall. In the Cisco world, we could have a dedicated appliance that does firewalling for us, but another option is to have our iOS router performing basic firewalling functions. And by a firewall, we're talking about a set of rules that dictates what traffic can flow from one interface to another interface. And while the commands to configure an iOS firewall can be somewhat complex, what we're going to do in this lab is to leverage SDM, Cisco's Security Device Manager, as we have done in previous ISCW labs. And in an enterprise network, we may want to set up a firewall to, for example, allow email traffic to come in to our email server, or web traffic to come into a publicly available web server. And in this lab, an application we are easily going to be able to test is the Telnet application. We are going to establish a Telnet session originating on the inside of our network and terminating on the outside of the network. Then, in reverse, we're going to initiate a Telnet session outside of the network and terminate it inside of the network. We are going to do that initially without the iOS firewall configured. Then, we are going to go through the Firewall Configuration Wizard, which is part of SDM, and we're going to notice the Telnet behavior after going through this wizard. We are going to notice that even though we can originate a Telnet session from within our network, we cannot go to a device outside of the network and Telnet into the network through the firewall. And while we are in the SDM firewall configuration screens, we're going to take a look at our CBAC settings. CBAC, that is context-based access control. We're going to compare CBAC with an ACL, with an access control list, and we are going to use SDM to configure an iOS access control list to permit Telnet sessions originating outside of the network, terminating on a particular Telnet server inside of the network. And we will conclude this lab by verifying we now have bidirectional Telnet connectivity to and from that internal Telnet server. First of all, let's take a look at the topology we're going to be working with. In this topology, we consider this PC that we're going to be configuring SDM from, router R1, and the serial 0/0 interface of router R2 to be inside of the network. Then, to the right side of router R2, beginning with router R2's serial 0/1 interface and including router R3, we consider that to be outside of the network. So the firewall we're going to set up is going to be on interface serial 0/1 of router R2. And prior to that firewall configuration, we are going to establish a Telnet session from that PC to router R3. And we will also originate a Telnet session beginning on router R3 and terminating on the PC, which is acting as a Telnet server. Next, we're going to configure our firewall by going through the firewall configuration wizard. After we do, we're going to notice that although we can still originate a Telnet session from the PC inside of the network, and we still allow the return Telnet traffic coming back from R3, we are not going to be able to originate a Telnet connection from R3 going into that Telnet server. But perhaps we do want this Telnet server to be publicly accessible. What we can do is modify our ACL settings using SDM. And what we are specifically going to do is we're going to tell router R2 to allow inbound Telnet traffic destined for that PC at IP address 192.168.0.50. After we do that, a Telnet session can be originated from router R3, terminating on that Telnet server. Let's begin our lab by setting up a Telnet connection originating on the PC inside of the network and terminating on router R3 outside of the network. We are now sitting at a command prompt on the PC inside of the network. Let's initiate a Telnet session to an IP address of 10.1.1.1. That's the IP address of router R3. And you see that we are able to log into router R3. Now let's go over to router R3 and verify that we can Telnet in the opposite direction. From router R3, let's do a Telnet to an IP address of 192.168.0.50. And we see the login prompt pop up. We can Telnet from R3 to the PC inside of the network. Let's go ahead and disconnect that Telnet session and go out to our SDM interface and walk through the firewall configuration wizard. From the main SDM interface, we click on Configure, and then on the taskbar, we select Firewall and ACL for Access Control List. And notice we have a couple of options. We can configure either a basic firewall or an advanced firewall. The basic firewall option, that's going to apply a predefined set of rules to protect our network from common types of attacks. However, we cannot configure a DMZ, a demilitarized zone, using this basic firewall option. A DMZ, that's another segment of our network connected to a different interface on the router that might contain servers that need to be accessible to the outside world, such as an email server or maybe a web server that needs to be publicly accessible. That means with a DMZ, we would have an inside trusted interface on the router, we would have an outside untrusted interface on the router, and we could have a third interface that connected to this demilitarized zone, where we would have these publicly accessible servers. This would allow traffic originating outside of the network, perhaps on the internet, to come into our network and access our resources without getting into our production network. That traffic would stay in this DMZ. However, this is not an option for the basic firewall. It is if we use the advanced firewall option. With the advanced firewall option, we can optionally have a DMZ, and we can either apply predefined rules or our own customized rules to protect our private network from attack. In this lab, let's use the advanced firewall option. We've already clicked on the advanced firewall button, and we see a sample topology showing potentially 3 different interfaces. We are not going to set up a DMZ in our example, but we could have that optional third DMZ interface containing publicly accessible servers. Let's click on Launch the selected task to begin this firewall configuration wizard, and we are provided with some summary information about what the advanced firewall configuration wizard does for us. We click Next, and now it's time to select our inside and the outside interfaces. In our example, we want serial 0/0 to be our inside trusted interface, and we want interface serial 0/1 to be the outside untrusted interface. And a potential challenge here is if we were running this SDM configuration wizard and we were currently located outside of this router, in other words, we were coming into this router on serial 0/1, do you see how we could potentially lock ourselves out? Therefore, if we want to allow SDM access from an outside interface, there is a checkbox that we can check to allow that. However, in our case, we are connecting through serial 0/0, a trusted inside interface, so we do not need to check that box. And if we were using a DMZ interface, you can see on screen, this would be the place where we would specify that interface. Let's click on Next, and we receive a warning just letting us know that we cannot launch SDM from that interface, serial 0/1, after this wizard is complete. We understand that, so we click OK. And that brings us to the Advanced Firewall Security Configuration screen. We can select the general level of security that we want applied using this slider bar. Notice we can go from high security to medium security to low security. The high security option, that is used to prevent the use of specific applications on the network. The medium security option is used if we want to permit those applications, but we want to track those applications. And finally, the low security option is used if we do not need to track the use of those applications. In our lab, let's use the medium security option, and we can preview the commands that are going to be entered into the iOS. Notice the configuration contains a series of IP inspect commands. This is using a feature called CBAC, Context-Based Access Control. One of these applications may begin on one port and then switch ports, and we're not quite sure which port it's going to be using during that application. What CBAC can do for us, it can notice when we are using one of these protocols to initiate a session from inside of the network. It can notice when we start to use a different port number as part of that application. It can dynamically create an access control list to allow the return traffic coming back in from outside of the network, only for that specific application flow and only while that application is running. After the application stops, or we have a timeout occur, this dynamically created access control list is going to be deleted. And as we scroll through this preview of the configuration, we notice several other commands, and the beauty of using SDM is we do not have to have an in-depth understanding of these commands in order to configure a very robust security configuration. Now with medium security selected, let's click on Next. And as we were scrolling through the preview of the commands to be applied, you may have noticed there were DNS names, perhaps for instant messaging services out on the internet. Therefore, we need to configure this router to point to a DNS server. For this local network, we have a DNS server of 192.168.0.1, and we see a very readable summary of what this configuration is going to do. For example, under interface serial 0/0, we see that we are going to apply an access rule to prevent IP spoofing. We're going to apply an access rule to deny traffic sourced from a broadcast address or a loopback address, but we are going to allow all other traffic. In other words, if we are inside of the network, we are going to be able to send traffic outside of the network. And unless we're using one of those applications that changes port numbers, the return traffic is also going to be allowed. We also have a set of rules for traffic coming back into the router, applied to the outside untrusted interface. Let's click on Finish, and in this network we are running EIGRP. In fact, routers R2 and R3, they are EIGRP peers. However, if we put up a firewall between them, could that impact the exchange of routing information? Well, not if we use this option that we see on screen. We can choose to allow EIGRP updates to come through the firewall. That's what we want to do. We click on OK, and then we click on Finish. And then it takes a few moments for the router to apply these configuration commands. At this point, we have gone through the iOS Firewall Configuration Wizard without going out and making any more adjustments. Let's do this. Let's go back out and see if we can now telnet bidirectionally between the telnet host inside of the network and router R3 outside of the network. From our PC, let's once again do a telnet to an IP address of 10.1.1.1. We are beginning this telnet session inside of the network and terminating it outside of the network. And it's interesting to note that we are allowing return traffic for this telnet session. However, what would happen if we went out to router R3 and tried to telnet back into our telnet server? Let's try. On router R3, let's do a telnet to an IP address of 192.168.0.50, something we were able to telnet to just a few moments ago. And notice in this case it comes back and tells us that the destination is unreachable. The gateway or the host is down. What is happening is the router is now preventing a telnet connection originating outside of the network from coming through the router and terminating inside of the network. However, in our case, let's imagine that we want outside users to be able to use Telnet to connect to this internal server. We want to allow an exception to the rule applied. What we can do is go back into SDM and set that up. Back in the SDM interface, under the Edit Firewall Policy /ACL tab, notice we have two different panes. We have one window pane addressing access control lists. In fact, notice we can click on originating traffic or returning traffic, and we can select an interface to see what access control lists are applied to which interface and in which direction. And down below, we have another pane that lists various applications, because some more advanced applications can be difficult to match with an access control list. For example, once the application starts, it might change the port number that it's using. Fortunately, CBAC, context-based access control, can watch a conversation that is being set up for specific applications and create a temporary access control list that applies only to that session. Then, after that session ends or times out, this temporary ACL is removed. If we want to manipulate which applications are being watched, we can do this. We can click on the Application Security tab, and under the Application Protocols, we can drill down through this hierarchy of folders to find a specific application. For example, let's click on the plus sign next to the voice folder to expand that, and notice that we are watching H.323. When an H.323 voice over IP session is set up, Even though the H.323 signaling originates on TCP port 1720 by default, the actual voice traffic is streamed using UDP, and those UDP segments are encapsulating RTP segments, the real-time transport protocol. That's the protocol that carries our voice traffic. And here's the challenge. The port numbers for those UDP segments are going to range, by default in the Cisco world, from a port number of 16,384 through 32,767. We certainly do not want to create an access control list to open up that wide range of ports. However, with CBAC, we can notice when this H.323 session is being set up, which UDP port numbers are being chosen, and we can create a temporary access control list just for that session to allow the appropriate port numbers through. However, back to our situation, if we click on the Edit Firewall Policy /ACL tab again, what we're trying to do is to allow Telnet traffic originating outside of the network to terminate on an internal Telnet server at IP address 192.168.0.50. Here's how we can address that issue. For the returning traffic coming into interface serial 0/1, we want to add a rule. We can click on Add, and we want to insert this rule before the currently selected rule. Because these are processed top-down, we select Add and insert before, and the action is Permit. We want to permit this Telnet traffic. We can give a description to document why we are creating this access control list. Let's give this rule a description of Telnet server access. The source network can be any network. We are not concerned with the source network. It can be any IP address, but the destination host or the destination network, we want to specify a particular IP address, the IP address of that Telnet server. It has an IP address of 192.168.0.50. Which protocol specifically do we want to allow? If we wanted to be very generic, we could just leave it at IP, and all IP traffic could be sent coming into the network, going to that Telnet server. However, we are only interested in Telnet traffic. So let's click on TCP because Telnet is a TCP protocol, and we're not concerned with the source port. We're concerned with the destination port. We are sending Telnet traffic destined for this Telnet server. Therefore, the destination port is going to be the Telnet port of 23. We select Telnet, or 23, as the destination port, and click on OK. We see that this new rule now appears in our listing, and we can click on Apply Changes, which is a button just off screen. This is going to send the appropriate configuration commands out to router R2. It looks like we're done, so we click on OK. Now, let's go back out and let's see if we can telnet from router R3 to our Telnet server that resides inside of the network. From router R3, let's once again do a telnet to 192.168.0.50. And this time, we are successful. We have created an exception to the rule that was created as we went through our firewall configuration wizard. However, at this point, realize that the configuration that we have applied to router R2 has not been saved to our startup configuration. So as a best practice, after we are satisfied with the results, we would then want to go to router R2 and copy the running configuration to the startup configuration. Let's now review where we've been in this lab. In iscw lab number 4, we took a look at how we could configure a firewall on an iOS router instead of having a dedicated appliance. That might be appropriate for smaller environments. And even though a firewall can address a wide range of applications, for our purposes in this lab, we used the Telnet application, and we saw that we could telnet bidirectionally to and from a Telnet server inside of the network and to and from router R3 outside of our network. Then we went through the SDM firewall configuration wizard, and after the wizard was complete, we observed that even though we could still originate a Telnet session from our Telnet server inside of the network, we were no longer able to telnet from router R3 to that internal Telnet server. We then went back into SDM, the Security Device Manager, and we observed some of the rules that had been applied by this firewall configuration wizard, and we discussed CBAC, context-based access control. And we discussed how CBAC could help out with applications that originated on one port number and then changed to a different port number. Those types of applications can be very difficult to track using traditional access control lists. However, in our lab, we were simply using Telnet. That can be tracked using an access control list. So that's what we did. We created an access control list to say that we did want traffic originating from any IP address to be able to pass through our router R2, to an internal IP address of 192.168.0.50, the IP address of our Telnet server. And we concluded our lab by going to router R3 and verifying that we could now Telnet to that internally located Telnet server.